Hey everybody, my name is Christopher Mick, and I run a small STEAM educational nonprofit out in Hudson, Wisconsin. Some of you may have been out there, but I am here for my Minnesota friends helping celebrate the virtual statewide Star Party 2020 edition. I'm working with the Bell Museum to provide a video here to aim specifically at my younger members that I do programs with out in the metro area. I do things at the Science Museum of Minnesota, metro area libraries, the YMCA, Boy Scouts, Girl Scouts, programs like that. And some of you may have never been to a star party before. And if I was there in person, I can kind of show you what some of these would be like, but we're doing it in a virtual setting and trying to give you some of the tools if you're going out for the first time to look up at our beautiful night sky. So welcome to the virtual star party. My name again is Christopher Mick. A lot of my younger friends call me Space Guy. So if you see me around, I respond to Space Guy and I'll ask you what you've seen and what you're excited about seeing in the future. So let's take a look at what we're going to do today. I've got a few slides here to show you, and then I'll go to some video stuff after that. So this is the second annual statewide star party. It runs for the week of November 9th through the 14th. And the Bell Museum is going to have a lot of awesome speakers and presentations linked on their website. I've put up some resources there as well for some printouts if you want to make some of your own things that can help you with viewing the night sky. And if we were doing something in person, it would look like this. So if you've been to a star party before, this image may be familiar to you, but it's usually an amateur astronomy group. You may have one in your community, an after-school club at the high school or at a junior college or at your library. And they'll usually have a collection of different types of telescopes. They'll find a nice dark open field and set up the different stations that you can kind of go around and see different objects in the night sky. Each telescope will be kind of trained on something different, and you can go by and ask the person questions about their telescope, what it can do, how long they've had it, how long they've been into astronomy, what we're looking at, and that. And so it's a lot of fun. You can find out about if you'd like to get more involved with a local club, or maybe some tips on your own first telescope if you're kind of researching what you would like to get, what you like and you don't like about certain telescopes. And it's a lot of fun. So we're doing it virtually this year, and so it's going to be to show you some things, teach you a few things hopefully, and then provide so you can have your own very good experience. So a little bit about me. Again, my name is Christopher, and I do a lot of programs, as I mentioned before. The one featured here on the left was from a Girl Scout program where they were going for their STEM badge. I was helping them with that. And then the one on the right, I'm very lucky in that with my work in my nonprofit and working with NASA as a solar system ambassador, I get to interview a lot of really interesting people, fly around the country and speak at conferences, and get to talk to engineers and find out about some of the latest things going on. So this photo is from a recent trip to the NASA Johnson Space Center, where I was a speaker at a Space Center Houston presentation. And on one of our off days, they took us to a part of the facility they have there, what they call the Mars Yard. So it's this area they have set up to look like the surface of Mars, and they have hills and craters. And what I'm holding is a lava rock. Lava rock on Earth is very close to the rocks on Mars. So they import all this lava rock and put it all over their field. And they test out equipment for potential use on Mars by astronauts. So this is a rover design they were testing out to see if this would be a good way to go for a rover to help astronauts travel around the surface of Mars. And we got to check it out and get a ride in it. And it's pretty amazing. And then I get to bring all that information back and share it with audiences like you. So I'm pretty excited about my job. And tonight is a really fun talk to share some of the interest I have in being an amateur astronomer and hopefully share that kind of excitement and passion with you. So some of the things we're going to talk about tonight. Making your own planisphere is an activity I have linked up on the website where you can do a printout and make your own kind of star chart to see your corner of the night sky and find some constellations and things that you might want to look for when you get out on a clear night. We're also going to feature some neat things to see in the November sky. And as I talked about before, provide you some tips for a successful viewing experience if you've never gone out to do a night sky experience. That'll hopefully help you have a good time. And then some resources for you, books and links and other places you can go, because my session is going to be only about a half hour, and there's a whole lot more you can learn. So if you want other things, we'll have some resources there so you can keep the learning going. So the planisphere I talked about, this is what it looks like. So there's some links on there. The one on the left here is the planisphere holder that'll kind of fold over on this line here right through the middle. And then this is your star chart that'll go inside. that. And then this grayed area you'll cut out with a pair of scissors, which will provide the window into your star chart. And then if we look at the next slide here, this is what your completed planisphere would look like. So it has the months along the top, and then you can get specific to the time of day, and then you can rotate that to the current month, the current day, and the current time, and you'll see what should be available in your night sky. Now, one thing I wanted to draw your attention to, this particular chart says 35 degrees north, and what that means is that ties into the latitude and longitude of where you would most see a night sky that resembles what you see in the viewer here. So if you haven't heard of longitude and latitude before, you may have had some experience with that. If anybody's played the game Battleship, you've kind of done longitude and latitude. It just isn't called that. Usually it's a letter and a number. So for example, if you say, I'm firing at A12, and you know how this goes. You find on your pegs, you go up to A and you go across to 12, and then you say hit or miss, or you sank my battleship. So that's a version of longitude and latitude. And this old-timey map I have featured here on the bottom shows longitude and latitude lines drawn on a globe of the Earth. So it's the same kind of concept. It's those coordinates, but instead of letters, they're using numbers for that. So when if you have access to a tablet device or a smartphone, the GPS setting will allow you to show your current location. So when I do that for where I am at here in Hudson, Wisconsin, on the border between Wisconsin and Minnesota, I get 44.97 as my latitude. So when I use a ruler and I draw straight across from Hudson, that actually runs right into the Twin Cities area in Minnesota. So I thought that's a pretty good latitude line to provide for the correct map for everybody that might be accessing this recording and wanting to print out their own map. So you'll note the difference. This map I made for a different group a couple of years ago was at 35 degrees north. We're almost at 45 degrees north. And so that's why the map I have for you on the resource links is at 45 degrees. So that'll match up with where we are on the globe and will provide a more accurate view of what you'll see in the nighttime sky. And the next slide. And here's another one I have linked that you can print out. This is a moon journal, which is put out by the NASA Jet Propulsion Laboratory. And it's a chart that allows for 30 days observation per sheet. So if you want to print multiples of these out, you'd like to keep track of your moon observations for a year, you can do that. Or you can just print out one if you want to try it for a month and see how it goes. But it's got areas where you can draw what the moon looks like on that particular date. You can note the date and the time that you went out. And if the weather's not good, that's data too. So you could just draw a line and then you could say cloudy or rainy or snowy or not visible, whatever the case may be. And then when you do get a good viewing, you can put all that information in. So some of my younger attendees ask, why does the moon look different at different parts of the month? And so this little picture here on the left, I think, is a great way to illustrate what's happening when you're looking at the moon. So if you look at the Earth globe here, this is the United States of America shown on the center, and you can find the Great Lakes, so it's always pretty easy to find where we are. We're close to the Great Lakes, so we would be in this area that I'm going over here with my cursor. So if you are standing out in your backyard and you're looking up at the nighttime sky, this is kind of representative of the phases of the moon during the period of around 30 days, like a month. So we're pretending the sun is over here in this example. And so if you're looking out and you're not seeing any moon at all, the moon is there, but you're not seeing it because it is directly opposite the sun. And so it's not illuminating any part of the sun that we're seeing. So you're not seeing a moon. And then you're standing here and you look up and you'll see a crescent moon. That's because the moon has started to move in its orbit around the Earth, and now the sun's illuminating enough to show you a crescent. And then as it gets farther away, it's illuminating a half, all the way until we get to a full moon. Because why? It's directly opposite the sun, so it's fully illuminating the entire disk of the moon. The moon also has a unique trait, and then it has a fancy term which you do not need to know, but it's called tidally locked with the Earth. And that means that the Earth, there's always one side of the moon facing the Earth. It's tidally locked, and so we're just seeing that one side. So we never see the far side of the moon, just the side that we see every night when we look up. But these are the cycles, and then it reverses course as it comes back around. So the Earth takes 365 days to orbit once around the sun, which is a year, your birthday to a birthday, and the moon takes 30 days to make an orbit around the Earth. And that's why you have 30-day chart here for your moon journal if you want to do that. So things to see in November. There are things to see every month, but some things are highlighted. They'll be special to that month to see in a prominent way. Mars will still be fairly bright, appears east-southeast at nightfall. So this is where a compass comes in handy. If you have an actual physical compass in your house, some people have, especially some of the Boy Scout and Girl Scout troops, they all have compasses for different projects. Or you may have a compass, again, on a smart device. A tablet or a smartphone will have a compass feature. So you don't need it every time you go out, obviously, in your yard, but you want to get bearings for what you're looking at. So if you take that compass out, then you can line it up with what you're seeing and say, oh, that house across the street with the chimney, that's to the north. That sidewalk is to the east, etc. That fire hydrant is to the west that I see. So then you know when you go out in your yard, what are those landmarks that indicate north, south, east, west? And then you'll know which way to face when you're looking for some of these objects. So if you go outside and face east to southeast, you will see Mars in the nighttime sky. On the nights of November 25th and 26th, a bright moon rises and sets with the red planet Mars. So that's an evening, if there's good skies those nights, where you'll see the moon and Mars kind of trek together through the sky. A bright Jupiter and a slightly dimmer Saturn come out in the south to southwest. On the 18th and 19th, you will find a crescent moon shining near both planets, Jupiter and Saturn. So that'll be pretty amazing. Hopefully, if there's good skies on the 18th and 19th, you'll get to see Jupiter, Saturn, and the moon all together. Then the Leonid meteor shower peaks after midnight on the 17th of November. Look to the head of Leo the Lion. This is one of those constellations. If you can look up on a star chart where Leo the Lion is, if you look to the head of Leo, you'll know where the Leonid meteor shower will be visible. And you may see 10 to 15 meteors per hour at that peak. So there are meteors that happen earlier. Midnight is pretty late. So if you don't stay up till midnight for that, you will still have a chance to see meteors earlier in the evening, but it's letting you know that midnight is the peak of the activity where you get into that 10 to 15 meteors. And a lot of my younger members call those shooting stars. And that's what meteors are. November's full moon arrives starting at the end of the month. So on the evening of the 29th, and then reaches fullness in the early AM hours of the 30th. So again, I think the peak actually for November is about 3:30 in the morning is when the moon will be its fullest. So it'll look very full on the evening of the 29th. You do not need to stay up until 3:30 in the morning to see the complete full moon. But if you're able to go out on the evening of the 29th and sneak a peek, you should see a very beautiful full moon that evening. And then, yes, you may be obsessed with space if, and I said that because this is my watch. My watch face is of a map of the solar system that is updated to real time. So I did a photo of my watch here today to show you how this ties into the chart we just looked at. Because some people ask me, well, why is Mars really visible and bright in the sky? Some of the time, but not all the time. And this is a great visual for why that is. If you can see my cursor, this is an overhead view of our solar systems. There's the sun in the center, and then that would be Mercury, Venus, and Earth as we're moving out, and then Mars. So this is why Mars is so prominent in our evening sky, because Mars happens to line up right behind us in our orbit now. So it's not always like that. If you look at a map of the solar system, it's kind of like musical chairs, and you yell out, stop, they could be at any old place around the sun in their orbit. But about twice a year, every 26 months to be precise, Mars lines up like this in the Earth's orbit, where they're as close as they can get to each other. So for us on the Earth, Mars looks very bright in the nighttime sky. And for engineers at NASA, that's when they like to launch their spacecraft to Mars. So you may have heard about in the news this summer, the next Mars rover, the Perseverance rover, it's a car-sized rover we're sending to land on Mars, launched this past summer. And other countries launched their craft as well, the United Arab Emirates and and China all launched spacecraft headed for Mars, and they launched them all this past summer because that's when this alignment allows you the closest travel time and the least amount of rocket fuel, and it's the best time to send spacecraft. Now, if you remember, another item on the chart was the moon appearing for a few evenings between Jupiter and Saturn. And I wanted to show the map for that reason, because that's why that will happen in late November, because Jupiter and Saturn are at this point in their orbit. So to us on Earth, when the moon rises, that's why Jupiter and Saturn will be very close to the moon, because they're in that part of their orbit. So I just wanted to share that because just perspective can kind of give you different insights into what you're looking at. And this is an overhead view of our solar system and kind of shows you why certain planets look the way they do in the nighttime sky. So another thing you're going to get into if you start to look at things that you want to find in the nighttime sky is charts like this. If you find a book at the library or you do printouts on monthly star charts for different websites that feature those, you'll see things like this. And I just wanted to explain a little bit on how you can read these and kind of understand what's going on. So it gives the names of some of the constellations, and you'll see some larger dark circles and some smaller dark points. This is a visual way to tell you that the larger dark circles are going to be the more visually brilliant, brighter objects in the sky, where the darker small circles are stars that will be harder to see, not as bright with the naked eye. And then if you can see on the bottom of the chart there, you'll see kind of an ascending scale of circles. And they have a magnitude number by them. So you'll hear that term a lot. The magnitude of this star is, or the magnitude of the planet is. That's just a fancy word for saying how bright it is. So on the scale, it's important for you to know, the smaller the number, if it's a 1 or a 2 or a 3, that means it's a brighter object in the nighttime sky. If it's a bigger number, an 8 or a 9, those are fainter objects that you can still see, but you might need the assistance of a pair of binoculars or a telescope to kind of pick those out. So that's what they're talking about on some of those different charts. Oh, this one is great. I borrowed this from the people at timeanddate.com because they put this great little graphic together. If we're all in person, I could just show you this outside when we're looking at the telescope. But this is another thing you'll see on star charts where we'll say, for example, Venus appears 40 degrees from the moon, east of the moon. And people are like, what does that mean, 40 degrees? So if you extend your arm all the way straight out and you're outside looking at the nighttime sky, and then you hold up your hand as is pictured here, either with your index finger or 3 fingers or a closed fist, etc. This is what correspondingly it gives you a measurement for degrees on a measurement map for the night sky. So if you just hold up your little finger and you're holding it out arm's distance, and you're looking up, your little finger represents about a degree in space. And if you go all the way over to the right, you see when you hold your hand out like that with your fingers kind of splayed, you're covering about 25 degrees, and that happens to be about the width of the Big Dipper constellation pictured there. So if you see any measurements, you know, okay, if it's 50 degrees away, if I do 2 of those kind of back to back and work my way across the sky, then I'm getting to 50 degrees, and you should be able to zero in on what you're looking for. So that's a great little, without having to look at charts or get out any measurements, you can kind of just use your hands to make the measurements over to find the object that you're looking for. And then meteorites. So as I said before, some people call them shooting stars. You may have seen one where it streaks across the sky and it's gone in a flash. And that's a meteorite actually hitting the atmosphere and kind of burning up, interacting with our dense atmosphere. And sometimes it either completely burns up and there's nothing left, or you get, this is one of my meteorites from my personal collection over here on the right. So it's in this little plastic case with a magnifier on the top. And unfortunately, if you were here, I'd be able to pass it around and scrape because you could feel the weight of it on your hand and you can look through the magnifier and see the different details. And I can't do that obviously in a virtual setting, but I wanted to show you a picture of it. And then on the left here, you have what's called a time lapse, where it's that little quick streak, but they leave the lens open. So the streak gets longer. They're making a longer impression of the image. And that's kind of showing it to you in detail. So some meteorites, as I said, completely break apart. There's nothing left. Others, like my sample, it breaks apart, but some of the heavier elements like this iron, melted iron, you can kind of see, here is the main composition element of the meteorite I have. And it was recovered, it landed in Argentina and South America. And I have that one in my collection. But that's what's happening when you see meteorites. We talked about the Leonid meteor shower. At the height of it, you'll see about 10 to 15 per hour. And so this is what you'd be looking for, is that streak kind of going across the sky, originating about where the head of Leo, the lion, is in the constellation. Oh, and then yes, I have my son Ted here featuring some of the excellent. If you've not been to the Bell Museum yet, I highly recommend it. They are open again, and they have an excellent display of some of their collection of meteorites. So Ted is showing you here their great big display case. They have information on their weight, their composition, when they landed. You can see the different materials. Some are kind of cutaway cross sections, so you can see the inside. So it's really interesting to see some of the different meteorites. And then this photo is obviously not from our area because we do not have cactus in Minnesota, but I wanted to show some different options of telescopes. Some you may have interacted with. And I am a NASA Solar System Ambassador, and one of my fellow Solar System Ambassadors posted this great photo when they were getting ready for a nighttime viewing event. So I just wanted to explain a little bit if you come up to a telescope like this. So this one has a viewfinder, which is this little small part on the top. And that's really great because that helps you line up with what you want to investigate further and get a greater deal of focus on. So the eyepiece will have little crosshairs in it, make like an X, 2 lines. Whatever you put in the middle of that X is going to be what the larger telescope is going to be trained on. So if it's a certain crater on the moon or a certain star you're looking for, you want to find it with the eyepiece, put that object right in the middle of those crosshairs, and then you can just do the fine focus adjustment, get it really sharp focus with the knobs, the control knobs on the telescope. Some people ask what this odd looking thing is on the other side. These are just counterweights. The telescope has a lot of glass and metal elements in it, and depending on how it's tilted, it can be very heavy on one side of the tripod. So to prevent it from falling on you or tipping over when you walk away from it, or not having to keep a hand on it to keep it steady, when you put counterweights that equal the weight of the telescope on the other side, they keep a balance, kind of like somebody walking on a balance beam where they put their arms out and then they stay balanced on the balance beam. So these weights equal the weight of this part of the telescope. And so it keeps it stable. And that's why you see no one by it in this photo. It's safe, it's stable, it's not going to tip over. Then the legs here are adjustable on the height. So hopefully if you're at a star party or your family has a telescope like this, or you have a neighbor or somebody in your community that is setting up a telescope and you're taking a peek through it, they can adjust the legs so you don't have to be on tippy toes or get up on a box. You'll be able to walk right up to it and see it. But the legs can be adjusted for how far out they spread and how high they go for that. So that's an example of one type of telescope. Oh, and then another great thing to see in the nighttime sky is the International Space Station. I don't know if you know this, but the space station makes passes over Minnesota several times. And you can have your parents go to this website, spotthestation.nasa.gov, and they can type in your zip code where you live, and it'll provide a chart of all the upcoming times that the space station will be passing over your area. Sometimes it's early in the morning when it's dark, and other times will be in the evening. It passes by in the daytime as well, but we can't see it during the day. So you're going to need to do those early morning or in the evening times that's slated that it'll be in your area that you can see. And at any given time, there's 3 to 6 astronauts always living on the International Space Station. It'll be very easy to see because on the chart, they will tell you the direction, like we looked at before. It'll be appearing in the east or in the west or the northwest. They'll give you the direction to look at, and then the direction it'll be leaving. And then they'll tell you how long it'll be visible. It might be 4 minutes, 5 minutes, 6 minutes. And they'll tell you how high in the sky it'll be. And that's very easy to find when you're out there because the space station is always the brightest thing in the sky when it's making a pass. So it's very bright. It's going very fast. The space station is traveling at 17,500 miles per hour all the time. So it covers the entire sky in just a few minutes. But it's pretty amazing to see and to know that people are living and working up there while you're taking a look at it. And it's a man-made satellite. The moon is a natural satellite of the Earth, and the space station is a man-made satellite where it's staying in orbit around the Earth, and we can see it when it goes by, like we can see the moon, but it's a man-made one. So that's pretty neat too. And your parents can select how they'd like to be notified. You can get it by email, you can get it by a text message on your phone, etc. So that's kind of fun. And then light pollution. I want to talk a little bit about light pollution. This is a really neat picture of the United States from space. And so the good way to figure out our area is you always go up to the Great Lakes. That's these dark areas because there's not going to be any lights inside the Great Lakes. So you go up to the Great Lakes and then you scoot over and then you know we're in this area, the Wisconsin-Minnesota state line in there. So what are all these bright lights? Well, this is a nighttime shot of the Earth, the United States, and you're seeing all the lights of big cities. So if you've ever been into the Twin Cities or a city on a road trip at night, you may have seen some of the lights that are causing this brightness. It's lights on the freeway, lights in high-rise buildings, lights in parking garages, lights in sports stadiums, all those things, lights at airports. So in evening, the bigger the city, the more lights. And so you can kind of tell wherever there's a big cluster of lights is a bigger metropolitan city area. And wherever it's darker, it would be a more rural, either farmland or smaller towns or less people in that. So if you've heard the term light pollution, that just means that there's so much light happening at night in certain areas that it makes it harder to see things in the nighttime skies. That's kind of the enemy of astronomers, is when there's a lot of light pollution. Because if they're trying to set up their telescopes and there's all those lights happening that I mentioned, all that light goes into the sky as well. It just doesn't go down to the sidewalk or down to the doorway. It goes everywhere. And the more light that is going up into the sky, it's harder and harder to see the stars and the constellations and things that are there. So hopefully where you live has access to some dark areas and there's not that much light pollution. But there's a couple tips to fight light pollution, even if you are in an area where there are some. I've done a lot of astronomy events at schools, elementary schools. And elementary schools by nature have a lot of lighting. They have lighting in their parking lot for where the teachers and the parents park. They have lighting for the sidewalks that lead up to the school so people aren't tripping on anything on the sidewalk. They'll have security lights around the building to keep the building safe by the doorways and the windows, whatnot, or maybe even out by their sports fields if they have that. So when we've done events at a school at night, we'll bring pieces of construction paper and things like that. Because if they can't turn off the lights, if they're like security lights, we will put a little kind of bell-shaped cover over the light to still have the light do its job. If it's lighting the sidewalk and it's on the side of the building, we'll put a cover over part of the light. The light can still shine down to the sidewalk, but then we're preventing the light from shooting out every which direction. So it's not shooting out to us sideways. It's not shooting up into the sky. It's hitting the paper and just going straight down to the sidewalk. And that cuts down on a lot of the light pollution and allows us to see more things in the night sky. So hopefully your community has nice dark skies, but if you're finding when you're looking for a spot to set up or you're seeing a lot of lights, maybe you can be somebody that helps kind of fight light pollution by making suggestions like that on just shades or covers for the lights where they can still light up what they need to do, but that they're not having extraneous lighting shooting everywhere that's kind of wasted. We don't need lights to go up in the sky. Because everybody would like to hopefully have a sky like this. This is my last slide, because the theme this year is celebrating our dark skies. And I wanted to find a great photo of a beautiful dark sky. So this is what I wish for everybody to be able to have access to, which is just you're seeing the line of trees out there in a field. You can see part of the Milky Way galaxy there, and just a sky packed full of stars. So that's what we're all aiming for. So I will stop sharing my screen here and then get to, so this is the space cave. So this is where I'm doing some of my virtual presentations, but I have a telescope pictured here behind me on the shelf. Not pictured, it's really here, but this is a Galieoscope, which is a student telescope I use. I'll get my cursor out of the way. And I have that real telescope right here. So this is the telescope without a tripod. So it's got a little locking ring so you can mount it to a tripod. And I use these with classrooms and for students because they're great. If you can see, there's no screws on them other than that locking screw. There's rubber bands. Then moving back, the rubber bands are holding it together. It's plastic in two parts. and it allows you, the students can assemble these telescopes. They can know where the lenses go. They can know how to put the smaller glass elements in the eyepiece together and learn how a telescope kind of works. And then they can go out and mount them on tripods and use those journals, like the moon journal I showed you, and kind of track and draw pictures of what they've been able to see. So this is a really good beginner kind of student telescope that I use. And if you're not using a tripod, if you can see, it's got a little sight area right here. So that's what you would be looking kind of as the eyepiece of the other telescope. You'd line up this with what you, the moon or star you want to look at. And if you line it up and have it right in the middle of that kind of V, then it's going to be showing up in the lens in your telescope. So this will be listed on the resource links in the description of the video too, a Galieoscope if you're interested in one of those. But you don't need a telescope. A lot of things you can see just with your eyes really well if you can get out to a dark sky and make your own observations. If you want to see more, that's when you would get into telescopes. So it doesn't have to be a telescope. It can be, your family might have access to a pair of binoculars. So if anyone's into bird watching or you have a hunter in the family, there may be a pair of binoculars around, and that can be something that can help you out. Some younger people have a hard time with binoculars because they can't get the binoculars to fit properly to the size of their face. So I always tell people a monocular is just a single lens, and that's when you can just close one eye and you're looking through the other, and can give you that closer view, but you don't have to worry about two lenses and kind of fitting them to your eyes. And so there's that option. And then you can also go up to the telescope like I showed in the picture, or you can do a simpler student telescope like this one. So those are some of the options you have for viewing, getting an enhanced view. And like I said before, you might have an astronomy club in your area, so it's good to kind of do, your parents can help you with a community search, because like here in Hudson, we have a space club at the high school, and we have telescope checkouts at our local library where there's a kit where you can check out with astronomy books and a telescope with a tripod like that. Other communities have amateur astronomy clubs and things like that. Some, if you have a college nearby, it might have an observation tower where they have their own kind of domed telescope and that. So that's something worth looking into if you want to do that as well. And as we talked about the Bell Museum before, they have a great deck where they set up telescopes, and they also have a planetarium where they can do great shows, kind of whisking you through our solar system and our universe, show you objects that you can look for later on your own. So that's another great resource that we have in our area. So the Planisphere activity I want to talk about. So that's what it'll look like again if you make the download and print that out. So again, it'll be on these kind of sheets here, so you can print them out, and then you're cutting out that gray area. You're making the fold, not trying to get too bright. You can make the fold on the line there, and then you put your star chart in and do that. The Bell Museum also has great, they do a star chart by the month. So if you go to the resource link we'll put in the description for the video, whatever month you're in, January, February, March, the Bell does one for each month, and they'll do the same thing. They'll put the things to see that month and the dates to see them, and they'll have them printed out on the star chart so you can navigate your way around the sky and find what you want to find there. So those are some of the resources, and your libraries are great. If you have a school library or regular library nearby, they'll have great books that you can check out and do that. It's like the night sky. So we were talking about looking for constellations, doing that. So you can get books like that, books talking about astronomy, stars and planets, if you want to learn more about the constellations, the history of how they were named, how they're used for navigation. Again, other star charts and things you can look at. Some pretty amazing pictures taken with telescopes. So there's all those resources. And then on the Planisphere, there's also Planispheres you can buy in the store. You're making a printout one. I modeled the one that you're having as a smaller one because I like those. You could throw those right in your pocket or a backpack. It doesn't take up a lot of room, but they're made huge, like the size of a dinner plate. So you have ones like this, which are kind of fun because it's got glow-in-the-dark material on it. So if you put it under a light for an hour before you go out, then it'll kind of glow green, and it's a fun way to use a star chart for that. So those are some of the resources that I'll have linked in there as well. And now for the last one is kind of tips to ensure that you have a good experience going out. So We have different tips for what time of the year we're in. I'm just going to focus on the winter ones right now because that's the season we're coming into. So you're going to want to do reconnaissance. You're going to want to go check out the area that you're thinking of going to use for looking up at the night sky. So if there's a nearby field or you have access to a farm area that's open to the public, things like that, a school grounds can be a good one. But you want to check it out because, like we talked about, you want to make sure there's no lighting that's going to get in your way. You want to find a good dark area. So if you check it out, you want to look for light poles, security lights, things that might be on like that. Accessibility, nice flat ground that you can set up in. As you saw those earlier photos, you're going to want to have flat ground to put up the tripod, things like that. You're not going to want to be on a slant or the side of a hill or things like that. The other one is you're going to want to dress appropriately. It's getting colder in the evening, so I tell people to pack a tarp, blankets to put down on the ground, depending on if it's wet or icy, the tarp. If it's not, you can just grab several blankets, but you're going to want to put something down. You're going to want to dress in layers. You're not going to be moving around a lot, so you can get cold going through this. So I always recommend layers because if you get warm, then you can take off an outer layer. And you still have enough on, but it's harder to get warmed up if you're cold to begin with than what you wore. So layers are good, and then a thermos bottle. If you have access to that, you can bring your favorite beverage, hot cider or hot chocolate, and that's a good thing to keep you hydrated and to warm you up if you're out for quite a while looking at different objects in the night sky. And then you're also going to want to have to look at your star charts or your telescope. If you do find this dark area, you don't want to trip on the ground walking over to where you're going. So there's the different kinds, but I have a combination flashlight like this, which has a regular flashlight at the front, but then on the second setting, it features a red light. A red light is really great to be able to read your star charts, see the focus knobs in your telescope, the ground where you're looking to set up, because red light does not make your pupils shrink down. You'll notice, maybe you've seen this before, when it's really dark outside, or if you just flip on the lights when you come in the house, your eyes kind of shrink down because your pupils get really huge to allow all the light to come in to be able to see well at night. And you want to maintain that so you can see the stars well. And a red light will not affect your pupil that way. So it allows you to read all the charts you're looking at, to see the telescopes, to see where you're walking, but you want to make sure you're just using the red filter. So a red filtered light is a really good thing to have handy when you're going to get into amateur astronomy for that. I'm trying to make sure I turn it off right. So a flashlight helps on that, and there's also apps for certain smartphones. If they have a red filter on that, that'll be something that'll work for you as well too. So those are some of the things that can help ensure that you're going to have a good viewing experience if you haven't done it before. And again, you don't need a telescope. If you have access to some of the things I mentioned, like a pair of binoculars, or access to a telescope, that can really help out your experience, or an astronomy club can be a great asset as well. So thank you for watching the video. First of all, I wish you success in your night sky viewing. If you have any questions, you'll be able to reach us. I provided email links for that as well. So thank you very much. Have a great Star Party week, and we'll talk to you again soon. Clear skies.